I gotta remember to do that in the beginning. These are called at this time. So, like I said before, this is 1.3 models and applications. Models and applications is just another word for word problems. So we're starting off with strategy. First one, we're going to read the problem, of course. Make sure you read it, get an understanding. You can read as many times as you like. You know, no one knows how many times it took for you to read it. So make sure you get a full understanding of what the problem is and what they're asking of you. If necessary, write each unknown as one variable. Not as one variable, in terms of one variable. Sorry about that. In terms, in terms of one variable. So you want to write each unknown in terms of one variable. And you'll see what I mean in a second. We're going to write an equation. And 4, we're going to solve. 5, we check. So now, the toughest part of this strategy are steps 2 and 3. So where a lot of people, you know, run into a little roadblocks or snares, if you may. Writing each unknown in terms of one variable and writing an equation will be the toughest part. Once you get to the equation part, then it's just the same thing that we did in last section when you're solving your equation. Going back to writing each term or each unknown in terms of one variable. What we mean by that is that you let one be x, and then the other unknown maybe be x plus 2 or maybe 3x or whatever. You want to write them all in terms of the one variable. What you do not want to do is call one unknown x, the other one y, and the other one z. Because from there, then what you have to do is what I found out is for every unknown, you have to have another equation for it. So that means we would need 3 equations to solve this setup. So you would have to create a system of equations in order to solve. And we're not in that section. And it's unnecessary for this section. So don't want to do stuff that's unnecessary. So let's look at the first example. Yeah, I'll just leave it there. I'm gonna try to write this little shorthand so I have room. All right, so we got the average yearly salary of a man with a bachelor's degree exceeds that of a man with an associate's degree by $25,000. The average yearly salary of a man with a master's degree exceeds that of a man with associates by $45,000. Combined, they earned, should be they, combined, they earned $215,000. Find the yearly salary of each. All right. So while we're looking at this, what you need to do is determine how many unknowns that you have. So notice we have a man with a bachelor's degree exceeds that of a man with an associate's degree. Then we also have a man with a master's degree, which exceeds that of a man of associate's degree. So you got 1, 2, 3 different people that are being discussed in this problem. All right. So I need an algebraic representation for each one of the people that are being discussed, or each one of my unknowns, because I need to find the yearly salary of each. So each one of them matters. So, and if I scroll up too far because someone's still copying, let me know. So we have the associate's degree, bachelor's degree, and then the master's. So now one of them has to be X, and then the other one we will write in terms of X. So if you go back to the problem, you notice that the associate's degree guy was used to describe both the bachelor's, the man with the bachelor's, and the man with the master's. So what we can do is let X be our associates and say, go back to the bachelor's degree. It says a bachelor's degree exceeds that of a man with an associate's degree by 25,000. So if I exceed someone by a certain amount, then that means that it would be your amount. Let's say if I exceed you by a certain amount, it would be your amount plus what I have or what I exceed. So that would be X plus 25. The bachelor exceeds the man with an associate's by 25. And then for the masters, it's X plus 45 because he exceeds the one with associates by 45. And that is, step 2 in the process. Step 3 is actually creating an equation. So the key word here, and there will always be a key word or two, a key phrase that will help you to establish what your equation will be. Here is going to be combined. If I'm combining something, I'm adding them together. So that means I will take each one of their amounts. You have X plus X plus 25. Let's see if I have enough room. Plus X plus 45. I did run out of room, but you said that equal to 215. So before I look to solve this equation, and I put parentheses there just to signify each piece. We had 3 different pieces. So that's why I have my parentheses around it, but we really don't need the parentheses. So now we can solve that. Sorry, truck out there. I was making sure it wasn't for me. So we're looking at step 4, which is X plus 25 plus X plus 45 equal to 215. Like I said, I didn't need those parentheses there. I was just using them to help me with the establishment of the equation. Combine your like terms. X plus x plus x is 3x. 45 plus 70 plus 40, 25. 45 plus 25 is 70. And I just saw something. Change that 215 so that we'll have even calculation to 214. I made a mistake, put 215, should be 214. But just so we have an even calculation. So sorry about that. I put 215. All right, so that should be 214 instead of 215. Now we'll go ahead and subtract 70. That'll be 3x equal to 144. Divide by 3. X is equal to 48. Oh.
Hey, Professor.
All right. Yes.
So basically, we're doing the same thing we was doing last week, but now we're using like phrases. Like
Yeah, right. We're using word problems to establish the actual equation.
okay,
Yep.
got it.
Yep. Someone put in the chat, are we supposed to be working on math labs as we go through each topic? Yes. So I haven't put a due date on anything yet, but when we get closer to closing out chapter 1, you will have a due date. So yes, it would be in your best benefit to progressively go throughout the my math lab homework as we go through the lectures. So last class we covered 1.2, which was the first section. 1.3 is what we're talking about today. And hopefully we'll get through it. But if not, if we do, we'll go ahead and get into 1.4 next class. And every day is opportunity for questions, so make sure you ask them if you have them, or shoot me an email, and I can answer them through email as well. But yeah, you want to go ahead and progressively be knocking these assignments out as we go throughout the lectures. So now we have an answer, but remember step 5 is to check to make sure you actually answer the question, because we aren't finished here. Because remember, it said what was the salary of each. So we would just go back to our establishment of what the variables, what were the variables or the representation for each unknown. And so here, 48 represents the associates. 48 plus 25, so that's 73, represents your bachelor's degree. And then 48 plus 45, 93
Look
represents.
ready to go.
Say it again.
You look ready to go somewhere.
Oh, that's not for me, right? Sorry. Yeah, I don't. Okay, good. Somebody said something about ready to go. I thought you were talking to me. All right. So 48, 73, because it's 48 plus 25, and then 48 plus 45 give you 93. And don't forget that each one of your answers, when you add them up, should give you that 214 that we had from the problem. Remember, each one of them combined is supposed to give us 214. All right. Questions before we look at another one? Oh, see, check. Do we have to add 1,000 back? No, because they wrote, if you look at the word problem, they did this right here, 1,000. or they said 1,000. I just shorted up 1,000. They did 1,000. So more than likely, all you have to do is put the 48, 73, and 93. If by some chance they wanted, my math lab would tell you before they mark it wrong. It should give you a hint that you know, put 1,000. But normally, when they write it like that shorthand, 48, 73, and 93 are good enough.
Hey, Professor, so do they have like a trial for my math lab? Because I ordered it, but it's on back order.
Yes, when you register initially, they should give you the option of either inputting that access code, purchasing access, or doing the 14-day free trial.
Okay.
So you should be able to get in that way.
All right.
Yeah, that's not how you price reduction. All right, so I'll give you guys a chance to write that before I say anything. All right, so your local computer store is having a sale on cameras. After a 40% price reduction, you purchased a camera for $276. What was the camera's price before the price reduction? All right, so when we look at something like this, if you worked retail before, if not, there's just a formula or a thought process that has to occur in order for you to get to where you're trying to go to, in order for you to get to the price reduction. And so what I mean by that, let me go another color. Yep, that wasn't it. So you have your original price. You're going to minus that price reduction. And that's going to be equal to the sales price. All right. So that's just going to happen regardless as to what information you have. Doesn't matter what information you have. You know that you have an original price. You know that you're going to have to subtract something from it, that price reduction, in order to get to a sale price. All right. One of them we already know without any calculation at all, and that's the sale price, which is $276. Somebody hit me in the chat. Let's see. My book is also on back order. I'm trying to sign up for the trial. Okay. I don't have the course ID on me. I can get it for you before we leave out. If somebody else have it, please feel free to share it in the chat. If not, I will shoot that to you before we get out of class. So we got original price minus price reduction equal to sale price. Sale price is $276. Price reduction, we'll talk about it in a second. Your original price, that's what we will call X. That's the unknown, the original price. Now, the price reduction is the tricky part, the one that always catches people off guard to some degree. We know 40% is the price reduction. Well, the price reduction, well, the 40% does not stand alone. First of all, recognize that in order to use the 40%, you have to convert that to 0.40. Move your decimal to the left, 2 places. And then you're always doing a percentage of something. You just don't put a percentage in there and say subtract a percent from the original price. It has to be the percentage of something. Of means multiplication. So if you think about it, the only thing you had initially was not the price reduction or the sales price, was the original price. So if you're taking 40% of something, it has to be 40% of the original price. So that means we're talking about 0.4 times X. Like I said, of means multiplication. You're talking about 40% of the original price. A lot of people make a mistake here and they apply that 0.4 times the 276 and they do some stuff within the same format, but you cannot take the price reduction off of the sales price because the sales price didn't exist initially. You had the original price, then you take the 40% off of the original price and then do your subtraction. So before we do the calculation, any questions on the setup? Appreciate you all replying in that chat, giving the course ID. Thank you very much. So we have X minus 0.4X equal to 276. Now here's the other place where a lot of people kind of get caught up on. We have X minus 0.4 X. We have like terms. We have to combine our like terms. Well, we are going to do that. You know, a lot of people, this is where like a lot of people make a mistake because they would divide 0.4 or they'll add 0.4 to both sides or whatever. But the first thing we would do, same thing as if we had X minus 5X equal to 276. First thing we would do is combine our like terms. Same thing happens here. And we can't, do something different just because we have a decimal and we don't see anything. Don't forget that what's in front of X is a 1. So essentially what you have is 1 minus 0.4. So 1 minus 0.4 is 0.6 X. And that'll be equal to 276. So make sure we are okay before we look to finish off the problem. All right. So now here we'll divide both sides by 0.6. X is equal to, 460. All right, any problems? All right, let's do another one.
Is that
Yes.
Is that 460 or is that 46.0?
Because of this decimal right here, it would be 460.
Mm-hmm. Okay.
Yep. And remember this, that X represents the original price. So if it ends up being $46, but your sales price was $276, then somewhere you did a miscalculation.
Gotcha.
Right. Yeah. All right. So let's look at this next one. I'm not going to squeeze it in there. All right, so let's see. All right, so your grandmother needs help. She has $50,000 to invest. Part of this is to be invested in non-insured bonds, paying 15% annual interest. The rest of this money is to be invested in a government insured certificate of deposit, COD, paying 7% annual interest. She needs $6,000 in extra income from investments. How much should be placed in each? So I'll give you a few seconds to finish writing that. All right, so we have two accounts here. We have one that's paying 15% annual interest, and the other is paying 7% annual interest. So that's how we'll start off labeling. Hold on one second. Sorry, everyone. All right, so we're looking at 7%. So we have two accounts, one at 15%, one at 7%. And let me do this. Let me scroll down some. So the interest earned, we're basing it on your simple interest formula. Simple interest formula, which is I equal to P RT. And I'll scroll back up to go to the other part. All right, let's see. This is deposit loan. I'm trying to ignore y'all. I'm trying to ignore all of them. So let's try to get back to this. Um, simple interest formula. So I equal to P times R times T. P is your principal. So that would represent your deposit or your loan. R is your rate. Don't forget to convert that to decimal. T is your time, and time is going to be in years unless said otherwise in the problem. Right now, of course, we're leaning on years. So let's look at establishing the P, R, and T for each account. All right. So let's go ahead and write that. P, R. All right. So the R and the T are already given, self-explanatory, 15% here. So it's going to go to 0.15, and time is 1 year. So every year she wants to earn $6,000. And then here, my rate, 0.07. And time is 1 year. So the same amount of time is going to pass or transpire for each account. So now, the tricky part here is the how you would set up the principal or representation for the principal deposit in each account. So $50,000 is the total amount that she has. Whenever they give you a total, but they don't give you any type of relationship between how much you're going to deposit in each account or how much you're going to do whatever, what you can do is let one of them be equal to X, and then the other one be the total minus X. So in other words, if I solve it and I get X is equal to 2,000, that means the amount that was deposited in the 7% account will be 48,000 because it would be 50,000 minus the 2,000. So that's how you always can do it. And like I said, that is the total minus X. The total amount was 50,000, and we subtracted X from it. And also, it doesn't matter if you do everything correctly. It doesn't matter which one you call X and which one you call 50,000 minus X. If you do everything correctly, you still end up with the same answer eventually, the same two answers eventually. All right. So we have that, and then also, so now we're going to use this relationship right here, and I want that to be red for future notes. And so there will be interest earned. And that, as a matter of fact, let me do it this way. The formula or the equation that we're going to use is that we're going to have interest earned, a total amount of interest earned, a certain amount of interest from the 15% account, plus a certain amount of interest to the 7% account. So that's the equation right there that we're going to use. And we need a piece for each one of these three.
Hey, sir.
Yep.
Is she trying to get 6,000 from each of these people, or
Nope.
6,000 altogether?
All together. And let's make sure that's said. Yeah, from the investments. Yeah, so she wants, and they probably could have worded it better to make sure that clarification was made. But she wants 6,000 from both of them added together.
So couldn't we just do what? Couldn't we just do 3 and 3 from each then?
If you do 3 and 3 in each, we don't know how much it's gonna earn. I don't know. But see, there are a whole bunch of different things you can play with because it's always good to get more than 6,000 versus less than and all that good stuff like that.
Okay.
I don't know what's going on in his grandmother's head. You know what I mean? Because
I know she should just go to Tesla.
Tesla. Or maybe you can just drop off 50,000 on the 15%. I don't know. You know what I'm saying? It just maybe there's more security in the 7, but she'll make more in the 15. So it's saying at least if I get 6,000, there's a whole bunch of, so all I'm doing is just playing with the cards that was dealt to me. You know what I mean? So
all right, my bad. Thanks, sir.
No, you're fine. It's a legitimate question. Legitimate question. Because that would eliminate a lot of the math in this thing too. So the total amount is 6,000. That's what we want to get. So that's just going to be the number of 6,000. Now the percentage, the 15% is going to be P times R times T. P was X. R was 0.15. And then the time is 1. So that's 0.15x. And then for the 7% was 50,000 minus x times 0.07 times that 1 year. And like I said, don't forget where we're pulling this from. It's P times R times T. P, R, and T. I will go ahead and distribute that, just simplify it so I don't have to do it later. So that 0.07 is going to be, let me do it like this so you can see what I mean. 0.07 times 1 is just 0.07. So I'm going to distribute that 0.07 to both pieces here. So that should be 3,500 minus 0.07x. So now I'm going to take this relationship and create my equation. Now if I should stay green, 6,000 equal to 0.15x plus 3,500 minus 0.07x. All right, so that is our equation, and now we can solve that. Questions before we look to do so. All right, so combine your like terms. That'd be 0.08 plus 3,500. Then subtract 3,500. I didn't mean to scratch that one out. $2,500 equal to 0.08x. Now divide by 0.08. So it's 31,250 equal to x. All right, so before we finish off this problem, questions on anything I've done up to that point? All right, so don't forget to actually answer the question. Go back and talk about the amount at 15% is X, so it'll be 31,250. Then we have an amount, so 7% was 50,000 minus X. And that was, how much was it? 18,750, yeah. And, you know, make sure you put when you're doing my math lab, put the answers in the right box. You know, because of course it'll mark it wrong if you say 18,750 went to 15% and 31,250 went to 7%. All right, so let's at least do one more word problem. That's gonna put that. All right, so we have the length of an American football field is 250 feet. No, that's 200 feet. Yeah, I ran that together. Should be 200 feet. I'll just write it better. So football field is 200 feet more than the width. If the perimeter of the field is 1,040 feet, I get it right. If the width of the field, if the perimeter of the field is 1,040 feet, what are the dimensions? So we have two unknowns. We got the width and the length. Those are our dimensions. We know the length of the field is 200 feet more than the width. So we call the width x. We can call the length x plus 200. Now they mentioned perimeter. So, and we know the football field is a rectangle. So since we have, I wanted it to be black, but it's too late. Since we have the perimeter being implemented, we can use the perimeter formula, which for a rectangle anyway, which is P equal to 2L plus 2W. We know what P is. The perimeter is 1,040. So we can plug in those three pieces into the formula accordingly. That's 1,040 equal to 2 times x plus 200 plus 2x. All right, so from there we can solve. We can distribute 2 there. 1,040, 2x plus 400 plus 2x. Combine your like terms. 2x and 2x, 4x plus 400. Do that. Subtract 400 from both sides. that'd be 640 equal to 4x. Divide by 4. X is equal to 160. All right, so finishing off the problem, X is W, so that's 160. And then 160 plus 200, 360 for your length. Questions on anything? See, so we got that plus 1.4 complex numbers. Okay, there's one more thing in this section to mention, so I'll go ahead and do that and then close it out. So solving for a specified variable. So they could ask us to solve 2L plus 2W, which is what we just finished looking at, for L. Say we want to solve that for L. If you want to solve a formula for a specified variable, your goal isn't necessarily to get a number, but just to get that variable by itself. So right now, we're just looking to get L by itself on one side of the equation. They ask us to solve it for L. So just like if I had, let's say 7 equal to 2L plus 5, and I wanted to solve it, first thing I would do is subtract 5 from both sides. See somebody in the chat? Interest problem in the test. I don't remember what I put in the test. Somebody asked was okay. Somebody asked was there an interest problem in the test? I don't know. I have to look. Look at the test review. That will let you know what's actually in the test. Please no. Well, I will say this: if I did put it in the test, it's not anything that will stop you from getting an A. You know, at the most it would be is one problem. So it wouldn't stop you from getting an A off the test. So yep. All right, so going back to this problem so we can close it out. And try not to be too concerned. You know, you got a whole bunch of other stuff that y'all can do to get your grades that you want. You know, one problem most definitely shouldn't consume you. But we're gonna subtract 5 from both sides, you know, if we were to do that. So in the same fashion, we would minus 2W from both sides. Remember, your goal is to get L by itself. So the 2W's will cancel on the right. And on the left, we have to be careful. They're not like terms. So we can't combine them. That would just be P minus 2W on the left side, 2L on the right. Once again, our goal is to get L by itself. So now I need to get the 2 off of L. So what we would do is divide both sides by that 2 in order to do so. And L is equal to P minus 2W over 2. And that will be it. So you don't have to get a solid number like L equal to 5 or L equal to 7. You just need to get L by itself. But what you do want to do is make sure that the right side is simplified as much as possible. So I'm going to show you the correct way and the incorrect way of simplifying this. So let's go here, call this the incorrect way.
Hey, sir, real quick.
Yep.
Might be stupid, but like, why do you keep switching the L from one side to the other side? Like at the
It doesn't matter. Normally for your final answer, whatever variable you were solving for is on the left side. So when you get into my math lab, they may have it like this and then have a box here so you can put the answer in.
Okay.
So
All
just
right.
getting used to it. But let me write this.
So either
Yeah,
way is right. Like,
yep.
okay.
X equal to 5 or 5 equal to X, if I can write.
All right.
Or X equal to 5, they're both the same thing.
All right. Thanks, sir.
Yep, no problem. Let me do this. Incorrect. So the incorrect way of simplifying P minus 2W over 2 is to cancel out these 2's and be left with P minus 2. P minus W, excuse me. So that is not going to work right. So the correct way of simplifying, if you just had to, is to remember that this 2 is under each term. So it needs to be applied to each if you want to break it apart. So that'll be P over 2 minus 2W over 2. Now your 2's can cancel. And your final expression will be P over 2 minus W. So this and this are the same thing. Like I said, P minus W is not. All right. Now, this answer right here is acceptable because notice the 2 could not divide evenly into each term. Now, let's say, and I'll put this right here because a lot of times people miss it. This is just a random example right here that I'm about to throw up. It has nothing to do with the problem. Let's just say if I had 4P minus 2W over 2. If you have this, then you do have to reduce because this 2 can go into the 4 and it can go into that 2 evenly. And that means you would do 4P over 2 minus 2W over 2. And then that will reduce down to 2P minus 2. So something like this, you must reduce. Once again, that problem originally, P minus 2W over 2, you did not have to reduce that because 2 could not divide in that P evenly. But if 2 can go into the term like 4P and 2W, then you are expected to go to that next step. Yes, sir.
So why wouldn't that be W? So
Did I leave something? Oh yeah, thank you. I made a mistake.
No.
Should be a W right here.
Okay, sorry.
Yep, that was my fault. All right. Anybody else? Anything else on anything I've written up to this point? All right. Let's see if there's anything left. We do one more and then be done with it. All right, so we'll do this last one and then we'll be done. got A equal to P equal to, oh, not equal, plus PRT. And we want to solve for P. Okay, so we recognize that here we want to solve for P, but we have P in two different places. In order to solve, we need one solid variable on one side by itself. So what we can do here is factor. We can factor P out. So pull P to the outside. What will be left out of the first term is just 1 plus RT from the second term. So that's P times 1 plus RT. So now if I want to finish this off, I can divide both sides by 1 plus RT. And so what, so P is equal to A over 1 plus RT. And that's it. Questions, concerns, or comments? All right. Well, try the stuff out. See if you get stuck on anything. Feel free to ask questions, whether it be through email or even next class. Either or is fine. People keep asking me, can they shoot me messages through Canvas or do they have to do email? Either or is fine. If you go through Canvas, I'll get it through my email, same email and everything like that. So outside of that, you guys have a good one. And I will see you on next class. All right.
Where did the 1 come from again?
Oh, let me go back to the screen. Make sure we good. So when you factor out P from both of these, notice there was nothing here with this P. So if I pull it out front, then what will be left is just 1. So if I were to multiply this P back, P times 1 is P, and then P times RT is PRT.
Okay.
All right,
Thank
is that
you.
good? All right. All right, take care, everyone.